My name is Olulana and I'm a PhD student in data science at WPI. Now, my research is about hidden or inferred fair learning to rank with unknown demographics. That's the topic. And what we're trying to do is we're trying to help practitioners decide whether to hide or infer missing demographics when they need them for fair learning to rank models. Now, what's a fair ranking? A fair ranking is a ranking where you have good representation for the available groups on the ranking, right? So if you look at this ranking that you have here, you see that you have the like an interleave of the red and the purple group. But on the one on the left, you see that you have just the red groups or the red group at the top, right? So this would be fairer than the one on the left. Now, why rank is important? Rank is important because we use them every day. If you go to Google right now on your phone, you would search and search for something. You probably would go most likely go for the first two results, sometimes just the first result, and you wouldn't look at the rest of the results or even the next page. Now, rankings are also used in loan requests, things that are important to people and affect their livelihood, school admissions, job opportunities. Now, so the question is, what do we do when we don't have our demographics and we need to be fair, right? So what usually would happen in the real world would be a company that wants to use a learning to rank algorithm to rank results would, and they don't have the demographics, would use an inference service, right? So we have some inference services here. They'll use inference services to get the demographic or the demographics of the items that they want to rank, and this inference services are not 100% accurate, right? So, for instance, you go to Gappy. Gappy may see Alex all the time as male, and Alex may be female sometimes, right? Alex can be female, so that means you would get error, like you get error from time to time, or you make mistakes with the inference. So our question is, if our inference algorithms are not 100% accurate, is it better that we infer, or do we just hide the demographics when we are using our fair learning to rank algorithms? So what we did for our experiment was we had 5 strategies where we would hide sometimes and then we would infer the other times, right? So for the first 2 strategies, the baseline strategies that we compared the other strategies to, and they were learning to rank algorithms that didn't have fairness incorporated into them. So the first one would infer the demographics, and the second one will hide the demographics. Then for the other algorithms, or the other models, which are either the first one was a fair learning to rank algorithm. So we had the fairness incorporated into the model, and then the other ones we incorporate the fairness after we've used the learning to rank algorithm that will rank the results for fairness. Right. So what we found out was, we found out we had interesting results, but I'll talk about 2 right now. What we found out for the fair learning to rank algorithm, where we incorporate the fairness into the model, we found out that the fairness improves as the inference error decreases. Right. So what that means is, the better the inference service, the better the fairness, or the more likely you are to be fair or fairer. So that means you need to check the accuracy of your inference service. You need to make sure that you're using very good inference services. That was one. And then another takeaway was that we found out that the strategies where you re-rank the list were better in terms of fairness and even utility than the fair learning to rank algorithm, where you had incorporated the fairness into the model, into the training of the model. And then for our metrics that we used to measure how good we did, or the strategies were, we had the exposure ratio to measure fairness, and then we had the NDCG to measure the utility of our rankings. That's how good our rankings are in terms of what we need. So the impact of the impact of our research was that we're able to help practitioners decide or to be aware of what they're doing when they hide or infer missing demographic attributes when using fair AI tools. And then we also raise awareness for the fairness utility trade off impact when inferring or hiding missing demographics. Thank you.